Hello everyone, I'm back with another exciting video. Welcome to Learning Science Daily. In our last video, we started exploring some key pharmacokinetic concepts, and today, we're going to pick up right where we left off. This time, we're diving into the plasma drug concentration time curve, a fundamental concept in understanding how drugs behave in the body over time. So, grab your notebooks, and let's begin. When a drug is given to someone, doctors can check how much of the drug is in their blood or plasma at different times. They take blood samples at regular time intervals after the drug is given. These drug levels are then plotted on a graph, with time on the x-axis and drug concentration on the y-axis. This makes a curve called the plasma drug concentration time curve. If the drug is taken by mouth, or another route that's not directly into the vein, it takes some time to reach the bloodstream. As it gets absorbed, the drug level in the blood goes up, reaching a peak level, then starts going down as the body starts to remove it. The body removes the drug in several ways. The body can remove the drug through urine, by breaking it down in the liver, a process known as biotransformation, or through other ways like sweat, feces, or breathing it out. In short, the curve helps us understand how long the drug stays in the body and how fast it's removed. The relationship of the drug level time curve and various pharmacologic parameters for the drug is shown in figure. MEC and MTC represent the minimum effective concentration and minimum toxic concentration of drug, respectively. MEC stands for minimum effective concentration. This is the lowest amount of drug in the blood needed to start having a useful effect. MTC stands for minimum toxic concentration. This is the lowest level at which the drug might start causing harmful or toxic effects. We assume that the amount of drug in the blood matches the amount in the body tissues, where the drug actually works. The onset time is how long it takes for the drug level to reach the MEC, that's when the drug starts working. The intensity of the drug's effect depends on how high the drug level gets. More drug usually means a stronger effect. The duration of action is how long the drug level stays above the MEC, meaning how long the drug keeps working. The therapeutic window is the safe range of drug levels in the blood, between the MEC and the MTC. If the drug level is within this window, it works well without causing harm. If it goes below MEC, the drug won't work. If it goes above MTC, it may become toxic. Key points are: wider therapeutic window equals safer drug. Narrow therapeutic window equals riskier drug because it's easier to overdose or underdose. Let's move on to the other key pharmacokinetics terms, which include peak plasma level, known as Cmax, time for peak plasma level, known as Tmax, and area under the curve, or AUC. Cmax is the highest concentration of a drug in the plasma after administration. Tmax is the time it takes to reach the maximum plasma concentration. And AUC is a measure of the total drug exposure over time. Now is the time for questions and answers. Question 1. At what time intervals should plasma drug concentration be taken in order to best predict drug response and side effects? And the answer is plasma drug concentrations should be measured at time intervals that capture Cmax, Tmax, and the elimination phase to best predict drug response and side effects. Question 2. What happens if plasma concentrations fall outside of the therapeutic window? And the answer is, if plasma concentrations fall below the therapeutic window, the drug may be ineffective. If they rise above it, there is a risk of toxicity or side effects. Thank you for listening to this lecture series. If you have any questions, feel free to drop them in the comments below. And don't forget to subscribe to Learning Science Daily for more educational content.